So hello students, in today's class we'll learn FRL unit, that is filter, regulator and lubricator. So in the previous class we had gone through fluid conditioner, which was nothing but primary air treatment for pneumatic systems. So in today's class we'll study the secondary air treatment for fluid, that is air, which
Here
is
in the
used in the
figure you
pneumatic
can see
system, that
a
is FRL unit, that is air preparation.
so here in the figure you can see a
FRL unit, that is air preparation. So this is filter, a regulator and a lubricator just before the direction control valve. So here in this case there is no primary air treatment shown here. Let's start with FRL unit. So you can see a small image on the right hand side here showing filter, regulator and lubricator, which is your FRL unit, that is secondary air treatment before the air is used for actuation. And here below a schematic diagram is shown, which you have to draw it in the exams, showing a filter, regulator and lubricator, direction control valve and an actuator. So this FRL unit is connected to the upstream high pressure line of the pneumatic system, saves space and improves efficiency. So just after the storage reservoir, your FRL unit is present, so which will be having, which is nothing but your high pressure line. Okay, so this FRL unit will be connected upstream next to the storage reservoir, so which is your high pressure line. And you can see the unit, FRL unit, it's very small. So because of presence of this FRL unit, so the efficiency of a system increases, and because of the size it even saves the space. How will you define FRL unit in pneumatic systems? So due to advance in manufacturing and machining technology, so independent devices for conditioning of compressed air, which is coming from the storage reservoir, so that is filtering, regulating and lubricating, is combined. You can see it is being combined into a single unit. So this unit we call it as FRL unit. So what is the function of filter, regulator and lubricator? So what filter does? Filter, so with water separator, removes dirt, pipe scales if any scales are present, rusting and condensate from the compressed air. We'll study this filter, regulator and lubricator in detail in the next slide. The regulator, so diaphragm operated. So regulators are diaphragm operated. How it is diaphragm operated, we'll see it in the next slide. So how exactly it is diaphragm operated. It's a relieving type regulator. Why we call it as relieving type? Then it keeps the pressure of air fairly constant with pressure fluctuations. If there are any pressure fluctuations in the pneumatic systems, so this regulator helps to maintain the pressure in the system. So lubricator, so it is a mist type and provides proper lubrication to all the parts. So in case of lubricator, a small oil is mixed to the compressed air. Okay, in order to provide lubrication for the pneumatic systems. That's why we call it as a mist time. So since there will be no lubrication for pneumatic systems, whereas in hydraulic systems, so since the fluid itself is oil, so that oil itself will provide lubrication to the hydraulic systems, whereas you don't have oil in case of pneumatic systems. So in order to have proper lubrication for pneumatic systems, you have lubricators. So this is regarding a brief introduction of FRL unit. Now let's go through these units separately, that is filter, regulator and lubricator. So regarding air filters, you can see a small image, a schematic diagram, a sectional schematic diagram of a filter, what all things are present in the filter, and a actual filter which is present in the pneumatic systems. So when you take a cross section of this, it will look like this. So what is the primary function of filter? As you all know, primary function of filter is to arrest dirt and smoke particles which are present in the air before entering the compressor. The same type of filter will be present before the compressor also, and even in the FRL unit. So primary function is to arrest dirt and smoke particles entering the compressor, pneumatic elements and actuators in order to prevent damage to the pneumatic system. So let's see the function of this filter. Air enters the shell or glass bowl. So this we call it as glass bowl. You can see a glass bowl in the image below here. So air enters the glass bowl or shell bowl at the inlet. So then air passes over the deflector. You can see a deflector cone which generates swirling action. So this deflector cone generates the swirling action, that is rotary motion. So because of this rotary motions, so there is a centrifugal action of air. So because of this, water and solid particles will be separated from air and fall under gravity. So then air passes through the baffle plate. So this baffle plate prevents the swirling action and forms a quiet zone here. You can see near this it forms a quiet zone. Okay, here below it forms a quiet zone, but above the baffle plate there will be swirling actions. So this baffle plate helps in order to reduce the swirling action below it. Okay, so that whatever the particles which are present in the air will fall under gravity. Okay, so after separation, air is passed through the filter. You can see after separation, the air will be passed to the filter, where fine, if any still fine dust particles are there, it is separated, and air, clean air comes out from the glass bowl from the outlet. So this is about the air filters. This is the function of air filters. Okay. So you can see the air filters, colorful diagram and schematic diagram. So both are schematic diagrams only. One is colorful, and the symbol used for air filters. So when you are building a pneumatic circuit, so this is the symbol which is used for air filters. So as you know, what is the function? So air enters through the inlet in the glass bowl, and the air passes through the deflector cone. So because of deflector cone, there is a swirling action which produces a centrifugal action. Because of centrifugal action, the dust particles will be collected due to gravity at the bottom, and there is a drain plug at the bottom in order to remove the dust particles which are collected here. And the baffle plate, so below the baffle plate, so baffle plate is present in order to have a quiet zone below it, and then the air will pass through the filter and will come out. Clean air will come out from the air filter. This is the working of air filters. Now let's move on to the next unit of FR unit, that is regulator. So we call it as air regulator. So what is the main function of this air regulator? Used to control the pressure of air inside the pneumatic circuit. So the function of the air regulator is in order to control the pressure of air inside the pneumatic circuit. So the function of this air regulator is similar to the pressure reducing valve. I hope you have learned this pressure reducing valve during hydraulic systems. So what does the pressure reducing valve does? If the pressure is higher but the system pressure required is less, it reduces the pressure to a required level used to adjust the supply pressure to a required level for a given load irrespective of airflow to maintain a constant pressure at the load. So irrespective of the airflow, so air regulator helps in maintaining the constant pressure in the pneumatic system. So it is acts similar to the pressure reducing valve. So if airflow is higher, it senses the pressure and the flow rate, required flow rate is maintained at constant pressure. If supply pressure increases, regulator decreases the flow rate to maintain the pressure at required level. So required pressure level will be maintained with the help of a regulator. As you have a regulator in your homes in order to control your fans, similarly you will be having a regulators in the fluid power systems in order to maintain the pressure. You can see a small cross-sectional schematic view of a simple air regulator. So inlet pressure, that is at upstream, you have pressure of 200 bars, and the spring force of this air regulator is 150 bars, and the force pressure required at the outlet, that is at the downstream, is 150 bars. So in order to maintain that pressure from 200 and reduce it to 150 bars, so this air regulator is used. So this spring force is set to 150 bars. If the pressure required is more, the springs set force will be increased, and with the help of this we can control the pressure in the pneumatic systems, similar to that of hydraulic systems. Now let's move on to the last one in case of FRL unit, that is lubricator. So air lubricator, you can see a schematic diagram of a air lubricator showing all the components. So in pneumatic systems, dry air cannot provide lubrication effect. As I said to you earlier, in order to provide lubrication, we should add a small amount of oil in order to have a proper lubrication in case of pneumatic systems. Whereas in case of hydraulic systems, that is not the case. Since oil is used, so automatically there will be lubrication in case of hydraulic systems. But here in case of pneumatic systems, so dry air will be present, so which cannot provide lubrication to the systems. So there should be a lubrication in order to have a lubricating unit. So this air lubricator will provide that lubrication to the pneumatic systems. As you can see here, a small amount of oil in the form of a fine mist is added to the clean dry air during secondary treatment. As you know, so FR unit is your secondary treatment. During in this air lubricator, a small amount of oil in the form of fine mist is added to the air. You can see this oil mist through this siphon tube, that is capillary tube, is been added to the clean air. So principle of this is similar to the that of automobile carburetor. Okay. So it has a cylindrical cell, so with oil reservoir. As air enters the inlet, its velocity will increase and pressure reduces due to Venturi effect. So there will be Venturi over here. So due to this Venturi effect, velocity will increase and pressure will reduce. So pressure at inlet is less than the pressure of the oil. So pressure at the inlet and the pressure at the oil which is present in the reservoir here, okay, will be less. So due to this pressure difference, oil in the riser tube, oil in the tube rises and mixes with the air at the inlet in the form of spray, that is oil mist. You can see because of the pressure difference between the inlet and the oil which is present in the reservoir. So because of this pressure difference, so oil will rise in the capillary tube here and in the form of spray, that is oil mist, will be added in the clean air. So needle wall which is present over here, you can see a needle wall. In order to adjust the pressure difference across the oil jet, so this needle wall is present and hence controls the oil flow rates. So even this, in order to control the pressure difference between the inlet and the oil reservoir, and in order to control the flow rate, needle wall is used. So friction between the moving parts is reduced in this way in pneumatic system, where the compressed air is mixed with a controlled amount of oil to achieve lubrication. So there will be definitely a friction between the components. So whether it is a pneumatic system or a hydraulic system. So in case of hydraulic systems, you have lubrication already there because of presence of oil. But whereas in case of pneumatic systems, you don't have it. In order to have that lubrication, a controlled amount of oil will be added in the clean air with the help of lubricator in order to have a proper lubrication for the moving parts in order to reduce the friction for pneumatic systems. So this is about air lubricator. This is about FR unit, that is filter, then air regulator and air lubricator. So let's understand what is Venturi effect in case of air lubricator. Now we have seen the working of air lubricator, that oil mist is added because of pressure difference between the inlet pressure and the pressure of oil in the reservoir which is there in the lubricator. Because of the pressure difference, so the oil will rise in the riser tube and will be added along with the air in the form of mist in order to provide lubrication. So what is that Venturi effect? So you can see I hope you know what is a Venturi meter. So you have a converging then diverging section. So a similar type of cross section will be there here at the inlet of the lubricator. So wherein the inlet air which is passing into the lubricator will be having a high pressure and lower velocity. So what this Venturi effect does is at the inlet here it is high pressure and low velocity. As it passes through this smaller section from diverging to converging section, so pressure, high pressure will be converted to low pressure and the velocity of air will increase. So the pressure here at the Venturi will be lower than the oil pressure. Because of the pressure difference, the oil will rise in the reservoir and it will be added to the clean air in the form of mist. So this is nothing but your Venturi effect. And this is the symbol which is used for lubricator. If you want to build a circuit and if you want to introduce a lubricator in the pneumatic system, so this is a symbol which is used. If this is the symbol present, so it indicates it's a lubricator. So this was about the first half of module 4. In the next half you will study pneumatic actuators. So these pneumatic actuators are similar to the one which you have already studied for hydraulic systems.